Alright, welcome everybody. Today got a good show, fun show planned out for you guys today. We're going to go back. My plan today is we're going to basically recap what we learned last week, and then we have a whole new lesson on dry ice, which I'm really excited. Dry ice is basically a solid. It's frozen carbon dioxide, but it's really fun. We're going to get into that later, but I want to make sure to start with a demonstration of a sonic boom and how a sonic boom is created. So welcome for those of you who have not been here. I'm Zaki42. This is my YouTube channel, and this is a live show, live YouTube science show that I do Fridays at 6:30 p.m. Central Standard Time for my Minnesota friends or wherever you're at in the world. All right. So apologies ahead of time if there is a storm kind of going around outside. So if it rains, that's just water. And we all like water. I have my water right here. Water's nice. It's good. I even got water over here we're going to need later. So yeah, there's also in my area, there's been bad internet connection. So if something goes wrong, the video glitches up, I'll make sure, or apologies last week, it was actually echoey, but that's okay. I'll make sure to record this and then get it out to you guys. Alright, so how is the sonic boom created? We're going to jump back for those of you who are not here. Grab our marker here. So I want you guys to imagine that there is an object. So this is an object. In this case, it's just this little black blob I just drew here. It's just black dry erase marker sitting there, okay? Let's imagine that this was somebody and they would say hi, and now they're going to say a sound and they're not moving, okay? So sound travels out in waves. So this is the sound. They said something, and it now just travels out the same distance, but also at the same rate, which is actually pretty cool. Which is why, so if I'm standing here and I'm not moving, I'm talking, somebody behind me could hear me, but you guys are in front of me, you could hear me. Eli Fell, say hi, Eli Fell.
Hi.
Eli Fell's over there. He's sitting off to the side of me, and he can still hear me. This is just proof that sound moves in all directions, but also at the same rate. So, what if we had an object that was moving? So if this marker cat was moving, you'd see the same effect, that there's sound bubbling up in all directions, but the sound waves at the front, if it was moving, would actually start to bunch up. So they'd bunch up at the top. I have a cool little picture here for you guys. So imagine a supersonic plane that goes faster than the speed of sound. When this happens, the airplane is outside of those bubbles. So you guys see how this airplane is outside of those bubbles? That means that it is breaking, quote unquote, the speed of sound. So when people say breaking the speed of sound, they literally mean that an airplane would literally break the sound barrier. I have an arrow drawn here because mathematicians can use an arrow to see how narrow the bubbles are to calculate how fast an airplane or an object is moving. Now this is really interesting to me. I think it's cool. Definitely, my recent video was actually how to make a supersonic rubber band whip, and the end of the tail of that whip, the string in our case, was actually breaking the sound barrier. If you want to go see that video, you can check that out after this live show today. Alright, so I want to replay the fact video that we did last week. It is the supersonic airplane facts. Pretty cool. There's 5 of them, and I really hope you guys enjoy. This is one of the favorite fact videos of mine today. Alright, so let's cue our supersonic airplane facts. Alright, so I hope you guys enjoyed that. It was really cool to make that, really fun to make that. To remind me to come back to this topic in our Q&A later on at the end of the show today, I pinned our picture here so I don't forget, and it's kind of cool to see. Alright, so we're going to start a completely new topic on dry ice. So what I'm going to do is I'm just going to quickly grab my glove here. I'm right here, don't worry. I have not left you. I'm going to grab something. So now, I cannot touch this in my hand, so actually I can touch it, but yeah. Okay, so what I'm holding here is something called dry ice. Now this is pretty interesting. It's actually, so when you think of water, it's ice, right? We love water in our cups. It's really nice and cold. So dry ice is actually frozen carbon dioxide, which is pretty interesting. I'm going to set this back down for a minute. By the way, this is negative 109 degrees, negative 110 degrees roughly. It sublimates at negative 109.3 degrees or 75.4 degrees Celsius. So it's very cold, and this is something, apologies, I mixed it up with liquid nitrogen in our last video. That's a completely other topic. Liquid nitrogen is negative 321 degrees, and this is negative 110 degrees, which is still really cold. And actually, if you look closely, you see it's melting, but it's actually not melting, it's sublimating. Sublimating means it basically, the dry ice here skips the liquid phase, and it goes to carbon dioxide. It actually puts it right into the gas, into the air. Alright, so I want to show you an experiment you've probably seen before. So this is a really cool experiment, and this is, you know, a vinegar, baking soda. We've done this before. So I have a glass here. And now I have the baking soda, and I'm going to put some baking soda in the glass. Now the reason we're doing that is because the baking soda and vinegar creates a chemical reaction which actually produces carbon dioxide, which is what frozen dry ice, which is what dry ice is. I'm going to open up our container here. And now can we get our candle lit quick? Adult supervision is required if you're doing the candle. And our flame is on. We're going to put our flame right here on our table. As you see, this is just a normal candle. It's a normal candle. Put it right here. Okay. So it's a normal candle. So what I have here is now vinegar, and I'm going to basically pour our vinegar into this container of baking soda. Alright, 3, 2, 1. And as you'll see, the baking soda spills over the top, which is kind of fun. The best part of this is the smell of the vinegar. Alright, so what's going on here is baking soda and vinegar creates a chemical reaction. Currently there's carbon dioxide now that's sitting on the top because that's what vinegar and baking soda produce. So when I had the dry ice, which we're going to pull out in a little bit, the dry ice is actually what, it's basically all the gas that's on top of here, it's basically that carbon dioxide, but it's actually frozen, which is kind of cool. So, you can pull our camera back up quickly. Oh, wait, quick proof that this is actually carbon dioxide. I have a candle here, and because fire requires 3 things, oxygen, heat, and fuel, when I pour it over here, the carbon dioxide makes the candle actually go out because it takes away all the air in the fire, and thus the air does not have the 3 things, so it cannot, the smoke is going on, it cannot burn, it cannot be fire. Alright, so bring our camera up for a minute. I'm going to grab a little chunk of dry ice here. We're going to do a ton of awesome experiments with this in a little bit because it's just so fun. And I have to say, by far, this is one of my favorite things to experiment with dry ice because it's just so awesome. By the way, I believe you guys know since, let me get our camera over a little bit. There you go. Thanks. So, by the way, liquid nitrogen is also a cool substance, but we have not found a reliable supplier, as we did with dry ice, which is pretty awesome because we still have dry ice here. We actually have 20 pounds today, which is pretty awesome. If you let this sit out, you'll actually lose 50% in 24 hours, which last week we were going to do, but we would have gotten a day ahead of time. We would have had to get like 40 pounds to have enough for today. We have a really awesome thing we're going to do today. So, after this dry ice video is going to come up soon, we're going to go and we're going to attempt to fog up. We're going to attempt to fog up a room with this dry ice stuff. So, what I want to do, just show you right now ahead of time, you'll see this a lot later. I have a little chunk of dry ice here. I also have, let me grab this glass. I have a little glass here. Watch what happens when I put the dry ice in this cup. Do you guys see that? It starts to bubble up because it's so cold in here. So, you see bubbles coming up to the water here. That's actually because the water, basically, because the water, this is hot water. It helps the dry ice to melt rapidly. Watch this. It's always fun to do. And you guys actually, that looks really good in the camera. I love learning this. This is so fun to experiment with. This actually creates carbonated water I'm not going to drink. Yeah, it's super fun. So, quick things just to note down. Yes, dry ice in here. It's frozen carbon dioxide, which is what was produced with baking soda and the vinegar. It is also a sublimates that, so it's around negative 110 because it starts to sublimate, not melt, because it goes into the gas state and it splits the liquid phase. So it sublimates at about around negative 109.3 degrees or 75.4 Celsius. So this water is warmer than that, and it's like what it would do if you put ice in here and it melts, but in this case it sublimates. So I'm going to set this off to the side here. It's just so fun to do. We have a ton of experiments we're going to do with this later too. I'm going to set this right here. So what we're going to do is, this is going to be something new we have not done. We have a big set change we're going to do, meaning that I'm basically we're going to go from here to another room, which is going to be kind of difficult. If something goes wrong, catastrophically wrong, I apologize. But we're going to try this, so we're going to go to a room. So we have a dry ice video, and when you come back, hopefully we'll be in another room. All right. Alright, need to get our camera up a little bit. So, that was a fun scene change. So, we're now in the bathroom. That's what the audio is. It's a working toilet. It's a running bathroom. And at least there's no windows in this one. So, I just filled this sink up with hot water and I have dry ice. This is the fun part. Whoa. So, this is the fun part. Look at all the fog that is coming out of the sink. And now, it's pouring over on the floor, which is awesome. Watch this. Oh, this is something that I've honestly wanted to do for like a long time. So, look at this. This is carbon dioxide. It's really fun. Don't worry, not carbon monoxide. Wow. And now you hear it bubbling if you listen really closely. Might be hard to hear through the camera. Alright, you want to put it down on the floor a bit. So, this is so cool. If you lay down on the floor and we get enough of this, it should be pretty difficult to see me now. It might not. We have not fogged it up very much yet, but it's kind of cool. Because this is all stuff from the dry ice. This is so fun. Eli Powell, what do you think of what do you think of this fog? Eli Powell's behind the camera here. He's helping with that. And look at this. So this is cool. So come back to the sink here. So if you notice, it's basically floating all along the edge. There is a soap bottle here. Soap bottle. Yes, I'll wash my hands too. So wow, this is super cool. So there's still dry ice in here. If I touch it, the dry ice, of course, it's cold. This will lead us to another question in our Q&A questions. Honestly, I could mess around with this for a while. What happens if we just put some soap in it? Oh no. Alright, it'll stop bubbling. So if you put soap in it, it's another experiment and starts bubbling up, and then we lose all our fog. So come down for the floor one last time. Let's see how good it is. You can't see me. Can you see me? Don't worry, this floor is clean.
Yes.
It's hard to see you.
Oh, you can see me? Okay. This is really cool. When you lay down there, there's like a layer of the carbon dioxide on top of you. Now, if you notice when I sneeze there, cough there, that's fun, how it goes everywhere. And I go, wow, the bubbles didn't catch up as much as I thought they did. So, if I put the drain on now, we'll have the dry ice back. But this is just so cool. Obviously, we have a toilet, we have this here, and yeah, it's a bathroom, right? So this is fogging up the counters. We'll note this. Oh, let's try it right now. I know I've been down here a lot, but this is as much fog as we're gonna get. This is so cool down here. Can you probably can still see me. Hi.
Hi.
Don't worry, the floor's clean. So I want to know what happens if we open the door now. Are you ready, Eli? Come through the door. How cool does this look? Oh, that's kind of hard to see. If I come out here, you can stay in here though. If I come out here, it kind of pours out here. And Mom will get everything out there. Okay, so this was fun. So let's come over here for a minute. I'll close the door. This is really cool. I wanted to make sure I could do this because it's just so awesome. So can we come back to this? Thank you. Thank you. So, this is so cool. So now I'll close the drain. The water's gonna drain out. Did you guys hear that? So do you know what that is? So this leads us to another experiment. Because dry ice is so cold, when I put it on a metal surface, that's harder to hear. But down here, because the drain cap is actually metal, it helps to, again, it's like with the bubbles, but it helps to melt it really rapidly. The human ear hears it as a loud screeching noise, which is what was going on there. So if I put this up, I know that's up now. We kind of lost that sound, but that was really awesome, way better than I thought it was. This is one of the coolest things. There's still stuff on there. One of the coolest things I think I've done. We've done. Oh, hi, Mir. Hi, guys. This is one of the coolest things we've done in this show. Now, this was just awesome. We're definitely doing a part 2 to this. By far, we're doing this. That was awesome. So we're gonna now attempt to come back to our studio to have more fun with dry ice. So we're gonna go into a little water facts video you've seen before. It was a little longer, and we're going to go reset at the studio. Okay, you can go back. Alright, oh, let me move my camera down a little bit. So, welcome back to the studio, everybody. That worked so well. That was the coolest thing by far I think I've seen for a while. That was awesome. We did the fire hand experiment a couple of weeks back, and that was kind of cool, but this was really awesome. I want to note something, because the water, you might be wondering, this will probably be a Q&A question, I'm sure someone will ask in the end. So this is dry ice, of course, right? There's actually an outer layer on here is actually water frozen, because water freezes at 32 degrees, and this is kind of negative 110 degrees, which is a lot colder than that. So there actually is a small layer of water, a little area of ice on the outside. Of course, it is still cold, so I can't touch it for more than a couple seconds, being safe here. So let's come over to our table here. We have a ton of containers. Cool things, cool experiments we're going to do with this. I'm going to pull these out. I'm going to set just a block of dry ice here. And remember, this is not the same carbon dioxide from our baking soda and vinegar experiment. This is real carbon dioxide that is frozen. So, or that is currently frozen. So, I have a really big container here. We're just going to have a ton of fun here. I have a different containers. I have a look, there's a tall one. This all has warm water. If you see a little seam, don't worry, it's just warm water. We're not doing anything goofy here. So I'm gonna take more dry ice. We're gonna set it off to the side. I'm gonna put dry ice in each container. Ooh, this looks like a cool block. Don't you just love that noise? Now watch. Yeah. And now we get to fog up this area out here. I'm sure the cats will be so excited. They are sleeping right now. Oh, yep, water splashed up. Don't worry, that's just normal water. Because water splashes when you put something in it. So, don't worry, that was just water. I'm going to drop that in more carefully. Put one more in here. And we can play with this stuff for hours, so we're definitely doing a part 2. Okay, so, yeah, this is one of the, this is just so funny, you have everything around. So I want to do something. I have glow sticks here. I have the green, I actually have a bunch of green, blue, and red ones here, glow sticks. I'm going to try to put glow sticks in here. Eli Fell, you want to pull off the light and go get those lights. They're going to shut off the lights, which will take a few seconds. I'm going to put glow sticks in here. Let's do this one green. We're going to do, thank you, this one blue, and this one pink. This sounds amazing. This is so cool. So this looks cool. It's a little darker in here. Wow. Oh, this is just
fun
so fun. Yes, this is really fun on Halloween. It's really cool. A really cool thing you can do. I want to show you something that are here, which I actually accidentally almost did with the sink in there. Oh, it's fun to blow at that. I have some just average dish soap here. We're gonna watch this green container, and I'm gonna put bubbles and some soap in here. And if we give it a moment, actually, I'm gonna take something to stir it around. Should I use the hammer here? Okay. So, if we wait a little bit, you're gonna notice something in here. Look at this. There are bubbles now forming on here, little dry ice bubbles. So, yes, the cool thing about this is for parents out there, parents watching, this is a really cool thing you can do, especially for younger kids, because I can come in here and I can safely touch these. They're actually a little warm, like they're not hot at all. They're like perfect, like bath temperature, shower temperature, which you guys would like if it's great. And it's kind of cool, it pops, and it's really cool, and it'll keep producing stuff for a long time until the dry ice runs out. And the dry ice, what it's doing when it melts, it actually slowly slows down as it gets smaller. Oh, I'll get stuff on the camera. And I can take a handful, and now I have some dry ice carbon dioxide bubbles that are on my hand. Great, safe to touch with kids. Hey, Eli Fell, come here. Eli Fell, grab a little handful of bubbles. What do you think of it? Are you ready to clap? We're going to clap. Oh, we already did. Grab bubbles. You ready? We're going to clap. You ready? Let's try it. Yep. Oh! Yeah, it's kind of cool when you do. You try it one more time. Ready? High five. 3, 2, 1. Yeah, it's kind of fun to do. It usually explodes. Otherwise, it kind of goes bubbles. So, as this goes, I have a little true or false that we're going to do quickly. And then we're going to do a cool experiment with the bubble. See with this? Woo, it's so fun to play with. Ooh, do you notice? Oh, the bubbles kind of fly everywhere too, and then they turn into carbon dioxide, which is fun. Cats love this. Don't worry. So, we get our camera up a tiny bit. So, I'm going to do a little bit here. So, Eli, I'll come in here for a second. This is going to be really fun. So, I have, don't look at the answers. I'm going to open up some true or false questions that we have in here. I have about 5 of them. They're going to be really cool. I'm excited for these. We came up with these. So, don't look at this. So, we're going to quiz Eli Fell. Because there's no chat through this, if you guys have, if you guys think you know the answer, tell someone you're in the room with, or, you know, just tell it to yourself. So, the first question, true or false? Dry ice is negative 321 degrees. What do you think, Eli Fell?
False.
Eli Fell thinks false. What do you guys think? So Eli Fell thinks false, so you can tell someone the answer is indeed false. Liquid nitrogen is negative 321 degrees, and I messed that up last week. Don't worry, even that happens to me. Happens to everybody, don't worry, because numbers is how you remember them. So, oh, sonic boom question. Oh, this is like, I feel like I have to talk louder than all these. So fun to do that. So, excuse me. True True or false? A sonic boom can destroy buildings.
True.
Eli Fell thinks true. What do you guys think? So this is true. Don't mean catastrophic. That doesn't mean to worry anybody at home. It can, like especially breaks windows. That's why pilots and everybody, they don't fly supersonic airplanes very often. Occasionally they will over like oceans, but they not often. They do not do over like residential areas. So that's nothing that you guys need to worry about. A cool thing I will mention: NASA is actually working on creating a basically supersonic plane that's only as loud as a car door slam. I don't remember what year they're going to come out with that, but that's a cool thing people out there, engineers currently right now, are working on. Our next question: true or false? Dry ice is the solid form of argon. Argon is it's a component of air, 0.9% of air. Eli Fell thinks false. The answer to this is false. Dry ice is indeed. I'll put on my glove again to be safe here. Dry ice is indeed frozen carbon dioxide. Of course, this one has a little water that's probably melted on the outside here. It leaves a funny mark on tables because it's so cold. So yes, this is frozen carbon dioxide, and it's really awesome. And people call this dry ice because it sublimates into, it does not melt. Melting means like it goes right from a solid to a liquid, and sublimates means it goes from a solid to a gas. In this case, carbon dioxide. Alright, you ready, Eli Fell? Ooh, this is a question about water, and you guys got to see a water facts video. So, oh, are you looking there? I think you should know this one too. True or false? There are over 350 quintillion gallons of water in the ocean. Eli Fell thinks true, and that is indeed, it actually is 352 roughly. Scientists estimate roughly 352 quintillion gallons, which is like a 1 with like 15 zeros. So quintillion, or quin means 5 if you want to know. So that's kind of crazy. So last one. Ooh, this is a fun one. Oh wait, never mind. This is one before. Okay. Do we have any more sheets? Sorry. We have a few other true or false questions we came up with. I just got sent some like audience questions, so we're gonna see some of these and see what they are. Oh, right here. Okay. Oh, this is a good one. True or false? Dry ice is a compound.
What's a compound?
Okay. What's a compound? Yeah, so it's just basically the form of that, the dry ice. Think of this as the dry ice. It's like a compound material. So the answer to this, just you can have a guess. True or false?
True.
Eli Fell thinks true, and the answer is indeed true. It is a compound. That's the topic for another video. I set that off. All right, thank you, Eli Fell. So that was kind of fun. So that was cool. Yes. So I was gonna do this earlier. That's what the last year's false question was, but I forgot when we went over to that because that was just so cool, the dry ice. So we're gonna have a lot of fun here because dry ice is awesome. So you wanna pull it up here again? Remember, don't worry, I didn't forget about this for the Q&A question. So we're gonna do something here. I'm going to take a container with a smooth lid. I'm going to gently push this off to the side. I'm going to gently push this off to the side, and I have a container with a paracord in it here that I put. We're gonna move this off to the side. So this is gonna be difficult to see for a minute, and then I'll hold it up so you can see it. So, and right here, I have a container. This is the dry ice. Don't worry. By the way, if you want to see the mark on the table, it's kind of fun. Look at that.
Just water.
Nice and cold. It's cool.
Just water.
Yeah. Oh yeah. That's just the water that's melting through because it's so cold. So. Oh, so fun. Okay, I basically put some dish soap in this container. As you see, matches this. Nothing else in here. Dish soap, that's in there. We put our dish soap in. I did this ahead of time so the paracord had time to sit in this. So, I've just put recently dry ice in here, we saw earlier. And what I'm going to do, actually, what I figure I should do is I probably should put more in just to make sure this reaction is as cool as it can be. Put that in, and now as you're going to see, it's going to start to bubble more, which will produce more of the carbon, it'll melt the carbon dioxide up here. So I have a rope, this is just normal paracord, and it has soap on it. Watch what happens when I grab this, and I'm going to try, let it string out a little bit, and I'm going to try to push it over the top like this. Oh, it pops, sorry, it takes a little bit sometimes to get it. So my goal here is to create a, oh, that's not there. My goal here is to create a bubble over the top of this. It takes some tries sometimes if you're doing this with me at home, if you have dry ice. It's not going. So, what happens here, I'm going to try to get it. What?
Too much soap.
Too much soap in this one. Oh, I see, okay. We actually drip soap in here, so now it's starting to create bubbles. And this is the same effect with the bubble that's coming out. Don't worry, experiments don't always work as you planned. Let me see if I can get that. Okay. Yep, now the bubbles have overwhelmed this. So, what you can do at home is if you take a container and then you push it over the container, it basically creates, did we seriously just get it?
No.
Oh, we didn't. Okay, so it basically creates a little bubble. It's a bubble film that goes over the top. So you see all the little bubbles here. It makes one big one a little a spear shape, which is kind of cool. So I'm gonna set this off to the side here. I want you to watch this now for a while. This is the bubbles, and I'll keep going until it's all over the container. And remember, super fun to play with. It does make your hands sticky, so I will definitely have to wash my hands later. So we have a fun experiment here. So this is gonna be really cool. We'll leave our camera here. So I have a container. This is a little hot water in here. I'm going to once again put my glove on to be safe. Remember, safety first, guys. I'm going to take a little piece of dry ice. I almost said a little piece of carbon dioxide, but that is actually also correct, technically speaking. So I'm gonna put dry ice in this container, and it's gonna bubble, right? Oh yeah. So this is an experiment. So you should not do this at home because we're pressurizing something. I'm not going to say anything else, but just don't try this experiment at home. We have safety precautions in place. I have a cap now. Now, because the dry ice is going to be pressurized, it's going to create this. Holy cow, that is crazy. It pushes the cap off, which is really fun. So, does it do it again? So, I'm going to try it one more time. So, it'll pressurize, and soon it should do that. Wow, that was really cool. So, now we're going to experiment with a variable here. How high does it go now if we put it on after like a third time at least? When the reaction has gone down. I'm not 100% sure. Oh, I did get that. I wasn't 100% sure if I sealed it all the way. So wow, this is really cool. So I guess I'll just do this one more time. Last time, so the seal popped there, and now the stuff is leaking out. Now it should get popped. Man, I caught it. That was kind of fun. Okay, so what happens now, I want to attempt with the bigger container. This has more hot water in it. We'll leave this here. Just fun, dry ice is coming out of here. Sorry, the carbon dioxide is. I'm gonna put on another glove. I'm gonna take a container. I'm gonna take my container here. I'm gonna put more dry ice in here. Wow, this is just so fun to mess with, you know, right? So I'm gonna put dry ice in here. Wow. And yes, it splashes. I got myself again. But seriously, watch. Yeah, this is not really hot water. Don't worry. It's warm water. What happens now, we put this cap on. This is bigger. So the thing is, if it leaks out, then it probably won't be a big explosion. I'll show you a version we experimented with earlier. We've done all these before. Don't worry. Did I get it on all the way? I did not. Yeah, that does it a lot sooner. Did you guys see that? Wow, that was really fun. Loud noise there too. Ooh, fun. Another container here. Can you guys hear the bubbling? Listen for a minute. Yeah. All you hear in the studio here right now is like a ton of bubbling, so this is actually really fun. So, we're going to mess with this again. I want to show you something with this. This is a failed version we tried, but the problem is I'll actually show you this. It still looks kind of cool when you do this. This is more hot water in here, normal container with hot water. I'm going to show you this so you know. Normal container with hot water. And I'm going to put this back down here. Same thing, nothing different. We're going to take more dry ice. We're going to put dry ice into this container. I didn't get splashed that time, yeah. So the container doesn't make a tight seal. So it kind of leaks out to the side, but still looks kind of cool. So you could have this sitting somewhere and there's like, oh, the pressure started to push up on this side. You could have it sitting somewhere and there's dry ice that's like spilling out the sides. Whoa. Doesn't that kind of look cool? I could set this here, the entire floor area here is fogged up. It was really fun. So, this is a cool thing, and put our camera up just for 1 minute here. I'm going to take, hey Dad! Dad's off to the side. This is his water bottle I just took from Dad. He told me I could, don't worry. This is something really cool I can do. Don't worry, this container has a hole, the top is open. You guys can check too. You see it's up, the top is indeed open. Never do this, but you have to be really careful. You could, but you have to make sure you're not screwed on. You have to make sure the top has a hole in it that's open, or else don't do that. So, alright, I'm going to take a dry ice cube and I'm going to put it in my dad's water bottle. Are you excited, Dad?
Yes.
Okay, now just like predicted, look what happens. Just predicting, right? Now watch when I put this on. You see there's a hole in the cap. Wow, this looks really cool. So I'm going to make sure I screw this on. I'm going to triple check this to make sure it's screwed on the right way. So now it is all the way screwed on. And look, so now you can have your water bottle and you're walking by, you know, whether you're an adult and you're at work. Well, not currently now with this pandemic, but ooh, that's kind of fun. Or I could be like with my friends, not now, of course, in the pandemic. I'll be walking around or like Halloween parties and you'll have a cup like this and you'll just go and take a drink out of the cup. This is Dad's cup, so I'm not going to take a drink of it. And you can just take, this is actually creates carbonated water. You can actually do this with like apple cider and you can do this with like apple cider, apple juice, and it creates like sparkling juice for like Halloween, and it's really cool. Or I've seen people, what they do is, here you go, Dad, we'll set this back. I'm going to take this, my goal now, the last thing that I want to do before I Q&A, I wanted to make sure I could do this. Take all the containers and just put dry ice in every one and see how much bubble effect we can create. You guys ready? It's like a little finale here. We're going to do our big one first. We're going to do next container, this one here. Take more. This one, and wow, we got so much fog like this, and we haven't even like got half the containers yet. Dad's playing with a thing that we just built up for him. Just gonna keep filling these up. And that, remember, splashes because it's tall, so you remember to do that. This is so cool, guys. Definitely, absolutely are doing a topic of dry ice again. So, funny thing just happened in the background. You want to pull up here where we talk. Eli fell. I just took the water bottle and put it by the cats, and they ran, which is kind of, it's fun to watch them do that. So you see, look at this bubble container here, and the bubbles will continually spill out. So, one thing I'm going to show you here. This is fun. I couldn't find my glove there because of all of this. I'm going to grab a little chunk of dry ice. It's hard to see anything now from all this, and I have metal. This happened with the drain earlier. Watch what happens. Actually, listen to what happens. Try to get this going. So this is going to be difficult to hear. So there's actually a high-pitched noise going on here. You really heard it while in the bathroom, so if you want to go back and do that again, but if you listen, you guys hear that a bit? It actually makes a scream. Now why that happens, the warm temperature, now it's cold, but the warm temperature of this hammer basically helps to melt this really rapidly, which creates the high-pitched noise. That's how the human ear receives it as. So if you listen, or receives it as that. You guys hear that? And it's really fun to annoy your friends with the noise. I did this at one of our last Boy Scout, Cub Scout Halloween parties. And you put it to someone's ear, and when they're not ready, and it just kind of, not the dry ice, but the sound, and it's just kind of a funny sound. So now we could also experiment with the variable of putting the hammer like this. Oh, that's loud. That's louder. I can put it like this. I can put it on the top. And as you see, it's the same thing in the water. You see there's actually little bits of steam coming off of this. If I go this close, like that, there's little bits of steam you see right on the top line here coming off. And this is it basically just melting. The interesting part, if I set this on a table like this, it's not actually going to, if I pull it up, the table will be dry. It might be a little icy, but it'll be dry. Which is kind of interesting because people will see, oh look, it's ice, they'll pick it up. But the table is completely dry, which is really awesome and interesting. So, this was a blast today. Don't worry, we're not over. The show is not over yet. I want to show you something so we can pull this up. This just, if you look at it for a minute, I mean, oh, this is just so cool. This is why I love science. You can do cool things like this, and look, now my table is fogged. This looks amazing. All right, I want to show you guys a couple things I've been experimenting with. This is a really old piano. These are old piano pedals. I want to do like a restoration video, do a few things with these. These are really old. It's pretty cool, pretty interesting. It's metal. Don't worry, there's no sharp pieces down here, and it's just metal. It has not rusted yet. So that looks really cool. I want to make sure I can show these things to you guys because these are current things I'm working on. My next normal video I'm thinking is going to be like something on ecosystems, which is what I want next week to be on. I also got a hold of these tubes from friends, which is kind of cool. Don't worry, the pandemic, we're all safe. So this is cool. A tube, I want to know, can you see me through that? Wow, you can, that's cool. So my goal here is, I don't know what to do with this, maybe a rocket, it's kind of heavy, so that's why we would have to be careful if we do a rock with that. That's what I'm working on. Alright, so we have come down to the part of our show, one of some of our friends, some of everybody's favorite parts of the show, where we do a Q&A. So, I have Q&A questions ahead of time. Few friends that might hopefully send me some. Shout out to Me101 if he's like watching. He has a cool YouTube channel. You should check him out. Alright, so these are a few questions. Well, I like this first one. If water freezes at 32 degrees, then why when you put the dry ice in the container, why does the water not freeze? So it actually, of course, I talked about it earlier. I'm going to pick up the one that was in the water ahead of time earlier in the sink. The most of the water is probably melted, but it's, if you notice, it's a lot shinier than our other block here. I'm not going to pick that one up because I don't have a glove on this hand, and we want to be safe here. Seriously, guys. So, we have the water here, and it actually, there is a smaller water here, which is from the sink. So it does melt, but it does not melt the entire thing, just because the water we have is like hot water. If it's cold water, if you leave it in long enough, it has potential, but because this carbon dioxide is bubbling up, my theory is that it keeps it moving. And remember, I can touch this for a couple seconds, a second, and it kind of, it starts to hurt your hand, which is why I have a glove on. And seriously, if you ever handle dry ice, please put a glove on, because if you hold it too long, you'll get frostbite, and nobody wants frostbite because it's not fun. I want to point out again, my dad is playing around with his cup because it's just so funny. He's squirting it, and it kind of like comes out. And this is just so cool on the table, right? All right, next question. See this one, okay. What is dry ice made of? Good question. Dry ice is frozen carbon dioxide. Quick thing, sublimates and melts. So if you have an ice cube, it melts in the water, and that means a solid turning right into a liquid. But sublimating means a solid into a gas, which is what happens here. So when I once again put on my glove and I pick out the block of dry ice here, this is the one that's not as smooth because it was not in water, which is my theory how you tell if there's not water in here. This is definitely harder. So yeah, so you actually if you come up really close, excuse me, come up close, you see, I'm going to try to get a good angle here. You guys see that all? That's carbon dioxide floating off the top of this area. It's sublimating off because it's not turning into a liquid. Once again, you set it down on a table and you pick it up, it turns into a, it does not turn into a liquid, which looks pretty interesting. People are like, wait, why is it not wet? It's dry. So a really interesting solid, really interesting thing to play with. Do your cats like dry ice? They sniff and they're like, well, it's really cold, and they probably don't like it because you don't like to touch it. They'll sniff and they go, oh, it's cold, and they'll walk away or you lose interest. They'll probably come over after we record this, and they'll probably sniff all these and hear the things, and they'll look in here and it's like, what? And they'll probably jump up and run around and try to figure it out, what it is. Excuse me. So, do I like dry ice? So, yes, I do like dry ice. It's really fun to play with. I mean, I just love putting on my glove, right? So, dry ice, it's super cool, and I really enjoy playing with this. That's why I said we're definitely, absolutely 100% doing part 2. Maybe not necessarily next week. My goal is to do like ecosystems and start an animal series. But seriously, dry ice is really just awesome, and it actually is decently easy to break. I just broke this. Small clump into another clump, in case you're wondering if it's easier to break. Yes, I just broke that into 2 clumps, and yeah, dry ice is awesome. One of my favorite solids by far, besides like the ground. Okay, that's a joke my friend would get. Okay, that can be the joke of the day. Oh, we didn't do that today, but we'll get one next week. So, can you show me a picture of the sonic boom again? I remember. Thank you for whoever asked that. That actually was myself, I realized. I'm putting this in here. So, remember, when an object breaks the speed of sound, it's literally going outside the waves of the sound. So if I jump back over here, an object is sitting and the sound waves move out. So if I'm talking now, the sound wave moves out in all directions, but at the same rate because it's not moving. Same thing if an object was moving faster, say 150 miles an hour, sort of like a plane. The sound waves do get bunched up at the top, which is why if I was standing on a road and a car was driving down the road, it would actually sound louder when it's by me because that's just the sound waves when it goes. Also because it's closer and the sound waves are all bunched up. So the picture again, once you ever hear the term, which I almost would promise you that you probably will, when they say an object breaking the sound barrier at supersonic speed like an airplane, they literally mean it breaks the sound barrier. Hopefully they mean that, unless they don't know what they're talking about and they don't know the science, which you will. And then the boom arrow, I just drew this in our video. You guys should go check that out, really. It's pretty awesome. The arrow, that's just mathematicians can use that arrow to calculate how fast an object is moving. I put this up here. So yeah, that's a video I did. It's called Supersonic Rubber Band Whip, or 770 miles an hour in the garage. And I also showed you in that video how to calculate the speed of sound wherever you're at, as long as you know the temperature, which is pretty awesome. So I really recommend checking that out. So, can I see your cat? They're sleeping over there, running around. Eli Fell's going to go grab the cat. Can I see the cat? Can we do a show on Dryas again? Yes, definitely. Absolutely. Oh, we got a joke. Let's go. How do trees access the internet? They log on. Sam, you're out there. I'm sure you're going to enjoy that one. So this is one of them. If you want to see, if you just don't know. This is like Valcano. Hi, Valcano. He loves science. He's looking over here like, what is going on with that? So, you want to go grab Candy 42? Candy 42, I call her, like Becky 42. Yes, I definitely want to do a part 2. What's your favorite school subject? Science. I love science. Science is like amazing. He's attempting to get Candy 42. She's playing right now. So she's not gonna come over. She's the calico cat, the orange, black, and white cat you will see. And she is in the Supersonic Rubber Band Whip video. Oh, she's over here. Hi, Candy. She really loves science. She's like my buddy always. Hi, Candy. How are you doing? She's like, wow, science. She's eyeing over here like, what is going on over there? Do you see the bubbles? Look at her, look at that. All right, you can set her down. Thank you, Eli Feld. So, cats are really fun. They love the science. They enjoy it. You'll be sitting at a table and they'll come up to see you. For those of you non-cat lovers, I mean, cats are cool. That's just me. Don't worry about it. Science is still awesome. So yeah, what is your favorite school subject? Science, physics, anything like that. I like I can like drop this glove and tell you how long it takes before it hits the ground. Or I can, this right here is just awesome. That's why I love science, you know. Please consider subscribing. So, and the last question somebody asked, should I subscribe? If you like this, if this was awesome, you think Dryas is awesome, even if you do, please consider subscribing. It really helps me out, you know, it's kind of cool. I have not gotten any friends messages yet for the thing tonight, which is alright. So, last time they had some pretty interesting questions on water, which I thought was interesting. Ooh, what happens if you have a quick thing I want to show you. So this is the water bottle from my dad. He was doing this. If you come here, it's like, ooh, look at that. You can't see the water bottle. Or if I back up, slowly back up. Don't want to run into this. Ooh, I'll point out something. This is a cool little blue light we have. It actually flickers. Let me see if I can get it to go solid here. Solid, perfect. What does that look like? So, what happens if I hold it here and if I, so it looks like it's kind of a different color. If I move over my light, now you can see it's more blue with the light because it's against a white surface. We could get some cool pictures like this for a video sometime. Definitely is something that I definitely want to do in the future. So, this was awesome today. And carbonated water, you can drink it. Dad, you want to come in here for a minute just to prove that you can drink the water. This is just carbonated water. It's like pop without the sugar. Well, did you drink out of it?
What? No.
Oh, no, he didn't. Okay, so I can drink out of this. I won't breathe. It just, it kind of makes your nose feel funny. Oh. Yeah, proof that I drink it. It's like pop, but without the sugar in it. So, non-sugar pop. There you go.
Seltzer water.
What?
Sparkling water.
All right, sparkling water. There you go. You can do apple juice. Make a little sparkling apple cider, which is pretty awesome. So, thanks for coming on today. We had a ton of fun. I mean, you want to put the camera over here just a second, quick. We did all this. Oh, it's kind of starting to fizz down again. I could take this block, and I could do that. Because now we have a bunch more steam. Now, if you watch it, I'll bubble up slowly, and then I can go like that. So, if you enjoy this, please consider subscribing. I do shows like this Friday, 6:30 p.m. if you're new here. And this is pretty awesome. I really enjoyed this today. This was by far one of my favorite episodes. We did something really cool, fogging up a room. It was pretty awesome. And yeah, so I'm really excited for this. I would really appreciate if you guys would subscribe. And my next week we're going to be on ecosystem, certain animal series. I do definitely want to come back to this. Dry ice here. Read out one last time. Dry ice, guys. Dry ice. If anybody learns anything from this video, know that dry ice is frozen carbon dioxide, and it is awesome. Absolutely awesome. Put that, just put that in here too. And get more bubbles out of that one. Now it'll bubble up. Remember, if you look, the bubble is coming up from this. You notice the bubbles coming up from, you see the bubbles down there? That is created from the CO2 that's floating on the surface once again. If anybody wanted to know that, was not in the Q&A. We're working on the live stream. We can't get we can't get the live chat on just because of the channel and how it's like rated. And I was experimenting with like getting music on the beginning and the end, but we're not going to do that because we had some experiment. We actually got like it's called a strike through this. Accidentally, we didn't realize what we were doing. So it's fine. So thanks you guys for watching. I'm Zachy42. This was awesome. If you enjoyed this, please consider subscribing. Tell your friends. Helps us spread this awesome science message. And yes, I am Zachy42. Once again, I will see you guys next Friday at 6:30 p.m. and I'll see you next time. Bye, guys.